Hi everyone, this is Sunita, Assistant Professor in EC Department, Siddhartha Academy of Higher Education, Bhimutla University. In this class, we will see a common base, common emitter, and common collector circuit diagrams, common base input characteristics, and common base output characteristics, early effect or base width modulation. Previous class, we have seen a transistor operation, transistor types, and everything regarding the transistor basics, circuit diagrams, connection like that. In this class, we will see the common base configurations, common base configuration, input and output characteristics, and the circuit diagrams of the common base, common emitter, and common collector. Same like CE configuration. Emitter is common, base collector. See one example: NPN transistor, N-type, P-type, and N-type. Input junction is forward bias, positive, negative. Output junction must be connected in the reverse bias. But here, both the emitter and collector are N-type. So how we can connect it in circuit means, so see here, leaving current, entering must be entering, and current flows, current direction must be positive terminal to negative terminal, positive to negative, leaving from the positive, entering into negative. Same PNP also. But CC configuration also same we will connect. Input junction. Base terminal is input, emitter is output. Input junction is the forward bias. This is NPN transistor. Forward means positive, negative. Output junction is reverse bias. Reverse both are N-type material. So IB entering, IC entering. Entering means here the C, IE leaving. So positive to negative. So here we will here the circuit connection is IE entering. See here, positive, negative, positive, and to leaving from positive, entering towards the negative. So arrow mark this is entering, this is negative, positive, opposite to the PNP transistor. This is common base configuration circuit diagram. NPN transistor common base configuration. NPN, emitter is N terminal connected to the battery negative terminal and base to the battery positive. Input junction is forward bias and output junction is reverse bias. N-type is connected battery positive terminal, base is connected to the negative. IB means base current, IC means collector current, IE means emitter current. We know that due to the lightly doped concentration of the base, IB is in terms of the microamperes, IE and IC are in the milliamperes. So what are these suffix? V means voltage, VEB means the first suffix indicates the terminal voltage and the second suffix indicates the configuration, type of the configuration. VEB means emitter voltage in base configuration. Same VCB means collector voltage in common base configuration. This is a supply voltage, emitter supply voltage VEE, and VC is the collector supply voltage. For biasing, we applied VCC at the output side, VEE at the input side. See, to construct input characteristics, the input graph, nothing but the graph drawn between input voltage to input current when output voltage is kept constant. The graph drawn between input voltage. What is the input voltage? VEB is input voltage and input current IE. We will examine here how the IE varies by varying the VEB. So the value of VEB varying, how the IE weight we will observe here by kept constant of the VCC. Output voltage kept constant. Then output characteristics means the graph drawn between output voltage to the output current, the graph drawn between VCB to IC when input current is kept constant. Here the input current is IE. When the input current is kept constant, we will observe how the IC varies by varying of the VCB. Here we should remember the input junction is forward bias, output junction is reverse bias. When input junction is forward bias, transistor is nothing but back-to-back connection of two diodes. Here the N-type and P-type, PN junction diode. PN junction diode is in the forward bias. Forward bias means by applying the VCB, which is greater, by applying the VEE, which is greater than the cut-in voltage, there is a flow of the charge carriers. There is a conduction of the current. The voltage at which diode starts the conduction, that means the current starts the rising the exponential curve, is called the cut-in voltage. We know everything in the we discuss everything in the operation of the PN junction diode. Here the same, the input junction acts as a PN junction diode in the forward bias only. So the graph drawn between VEB voltage and IE is nothing but the diode through the current, exponentially increasing current. So next, VCC equal to 0, and next put VCC value 2 volts or 4 volts, like that. Increase the VCC value and kept constant. Keep VCC value is constant. Then again vary the VEB, increasing 1 volt, 2 volt, 3 volts, like that, and measure the IE, emitter current. How IE is varies by varying the VEB. At the same time, we'll observe are there any changes in IE by varying the VCC. Previously we kept VCC is 0, now we kept VCC is equal to volts, like that. Like that, VCC increases kept constant and change VEB and observe the I. Those are the input characteristics. So, input characteristic, I already said the graph drawn between the input voltage and input current when output voltage is kept constant. Output characteristics are the graph drawn between the output voltage and output current when input current is kept constant. Already discussed what are these suffixes. The first suffix is the terminal voltage and the second suffix is the configuration. So for the configurations, we must know the x-axis and y-axis of the characteristics. Input output. In common emitter configuration, input is the base, output is collector. So common emitter base voltage, input VBE, base voltage in common emitter configuration, IB. Input current, base current, input current. The graph drawn between input voltage to input current when output voltage is kept constant. For the emitter configuration, collector terminal is output. In emitter configuration, BCE is constant. Output characteristics, output voltage to output current, IC, VCE, when input current is kept constant. Here the input current is IB, IB is constant. Common base configuration, emitter terminal input IE, VEB, collector terminal output VCB constant, VCB, IC, IE constant. For common collector configuration, input is base, output is collector. The graph drawn between VBC versus IB when VEC constant. Output characteristics, the graph drawn between VEC versus IE when IB is kept constant. We should know all these are the basics for the configuration. See here, input characteristics, the graph drawn between VBE and IE. VBE volts, input voltage, applied voltage, and current, emitter current, heavily doped, so milliamperes. IE increases rapidly with VBE. That means the resistance is very small because the input junction is forward bias, emitter base junction is like a PN junction diode forward bias. The applied voltage, if the applied voltage is greater than the barrier potential, that means the cut-in voltage for the silicon point, germanium 0.3, silicon 0.7, then there is a start of the conduction. See here, when VCB is equal to 1, here the VCB is equal to 10. Again, the output voltage kept constant another value and repeat the same procedure. So for that value, VCB 10 volts, the curves like here, VCB 20 volts, the curves like. If you observe the curves, IE is almost independent of VCB. That means IE is rapidly increasing. And here also the small changes, the curve shift towards the left. That means, see here, the curves shift towards the left. Up to this point, the curves start smoothly, same like. After that, there is a shift towards the left. Why? Because there is a early base width modulation due to this concept. That means VCB means reverse voltage. Whenever the VCB increases, the base width, the depletion layer width of that junction increases, resulting the base width decreases. The base width decreases. So as a result, for less voltage of the VBE, we will get the more current. See here, this much of current we will get at the 0.8 volts of the VBE applying. At the same current, this much of current, when VCB is equal to 10 volts, we will get just before maybe 0.79, 0.78 like this much previous. That means for less, the variation is very less. That's why noted it IE is independent of the VCP, but there is a small dependence of the VCP due to the early effect base with the modulation. The only the small variation, that variation, the less voltage will get the small little amount of the more current. V. The curve shift towards the left. So output characteristics. Output cuts the graph drawn between the output voltage to the output current VCB versus IC, VCB versus IC. When input current is kept constant, IE is constant, is a 0. Suppose IE is equal to 0 milliamperes. Then see, till there is a small amount of the current, that current is called the reverse saturation current, because in the collector region there is a movement of the collector base junction is reverse bias. Due to that, minority charge carriers will move. Based on minority charge carriers, those current constitute, that is called the uh, reverse saturation current in terms of the microamperes. You see here, IE input current is increases, there is a increase of the output current. We know that IE is equal to IB plus IC. IE equal to IB plus IC. There is a parallelism. That means at the starting, at the initial, if a very small change in the output voltage, there is a large change in the output current. After that, the output current is parallel constant. That means the output current is independent of the output voltage VCB. The output current depends upon the input current. Whatever the input amount we are increasing IE, the same amount we are seeing as the output. IE is equal to IB plus IC, but here IB is negligible because base is very lightly doped, very thin. The recombination is very less in terms of the microamperes. The both IE and IC, both currents are in terms of the milliamperes, for that will negligible. IC is approximately equal to IE. IE and IC is approximately equal. These are the output characteristics. The output characteristics classified into three regions: saturation region, active region, and the cutoff region. From both input characteristics and output characteristics, we will find out the resistance. From input characteristics, we will find out the input resistance in common base configuration. So resistance is voltage by current, the rate of change of input voltage to the rate of change of input current will give the input resistance. That means in the graph, take that any 2 points delta change VBE at the corresponding change in the I. And like we will find out the output resistance or not, the rate of change of in output voltage, the rate of change of in output current. In the output characteristics, take any 2 points on the graph, the change, delta change in output voltage to the corresponding change into the output current. Current amplification factor alpha, common base configuration, current amplification factor indicates alpha. The ratio of change in collector current to change in emitter current at constant VCB known as the current amplification factor. Amplification means the strength of the signal increases. How much amplification is done, we will refer as output by input. Output by input. If you give input signal, input current signal as a 2 volt, 2 amperes, the output after amplification, the output comes 10 amperes. What is the amplification factor? That means amplification factor output by input 10 by 2, that is equal to 5. 5 is the amplification factor. So like that, alpha common base amplification factor is alpha. Current amplification factor alpha is equal to output current IC by input current IE. The change in collector current to the change in emitter current at the constant of the collector to base collector to base voltage, the junction voltage kept constant at that instant. The practical values, common base current amplification practical values is less than 1. That means amplification is not 0.9 to 0.99, because if amplification factor is 1 means there is no amplification, output is equal to the input. In this condition, the CB configuration we are not going to use as a current amplifier, because the amplification factor is 1, approximately equal to 1. That means the CB common base configuration unable to do the current amplification. Output characteristics regions: active region, saturation region, cutoff region. In active region, IE increases, IC increases. Parallel. The IE is approximately IC is approximately equal to IE, because IB is negligible in terms of the microamperes. Emitter base junction is forward bias, CB is in reverse bias. Uh, uh, in the graph, IC is approximately equal to A. IC is not depends upon the VCB. Whatever the external voltage, the output junction voltage increases, that is VCB is not affect on the IC, because IC is depends upon the IE. The output current is depends upon the input current. That's why the BJT, bipolar junction transistor, called as current controlled current device. Current controlled current device. The output current is controlled by the input current. Current controlled current device. The suitable region for a transistor acts as an amplifier, active region. Saturation region, B and CB both are in the forward bias. There is a small change in the collector voltage will cause the big difference in the IC. There is a small change. Collector voltage, big change in the IC, because both here the output junction is also forward bias. Input voltage VCB change, collector current also change. The allocation for this region is to the left curve VCB is equal to 0. Cutoff region. Region below the IE, both the junctions are reverse bias. There is no current flow, only leakage current. Reverse bias means only minority charge carriers movement will take place. Those charge carriers current we will call the reverse current, leakage current, or reverse saturation current. Those in terms of the microamperes. So another concept we have seen in the input characteristic, the graph drawn between input voltage to the input current when output voltage is kept constant. Base width modulation, early effect. In the early effect also is called as a base width modulation. Name itself indicates the width of the base changes. Modulation means change. The width of the base changes, that is called the early effect. Why it happens means, whenever the output junction is in the reverse bias means the width of the depletion layer increases. The depletion layer width increases, the base width decreases. If you imagine the NPN transistor or PNP transistor, the structure, not a symbol, that is structure, layered structure, NPN, input junction, output junction. So output junction is reverse bias. At the junction, there is a formation of the depletion layer. If the reverse bias increases, that depletion layer width increases. As a resultant, the middle layer base width decreases. So that is the base width modulation. The width of the base is altered. Base width modulation. See here, reverse bias, junction, depletion layer. If you increase this voltage, reverse bias voltage increases. The width of the depletion layer increases. This will move here. So the base width decreases. The width of the base decreases. Previously up to here, now here. The width of the base decreases. This is called the base width modulation. The next configuration CE and CC, the comparison of CB, CE and CC we will see in the next lecture. Thank you.